Let's talk about optimizing our Heapify algorithm. So here we have a perfect binary tree with 7 nodes. Now, how many nodes do we have in the last level? 4. Mathematically, we can prove that in a perfect binary tree, half of the nodes are in the last level. Now, why does this matter? Well, in our Heapify method, we are iterating over this entire array and heapifying every item. Now, the whole purpose of this heapify operation is to ensure that every parent is greater than or equal to its children. So technically, we don't have to perform this operation for the leaf nodes, which happen to be half of the nodes in this tree. So to optimize our algorithm, we only need to heapify the parent nodes. So how can we find the index of the last parent node? Well, look at the index of these items. In this tree, the index of the last parent node is 2. How many nodes do we have in this tree? 7. So if we get 7 and divide it by 2, and then subtract 1 from the result, we get to 2, which is the index of the last parent. So the index of the last parent is equal to the number of nodes divided by 2 minus 1. So the first step in optimizing this algorithm is changing the upper bound of this for loop. Instead of iterating over the entire array, we want to iterate over only the parent nodes. So the index of the last parent is array.length divided by 2 minus 1. But we're not done yet. We can optimize this further. In this implementation, we're starting at the root node and traveling down the tree. Every time we get a node and heapify it, we have to recursively go down until we make sure that node is in the right place. So we're going to have a lot of recursions. The taller a tree is, the more recursions we're going to potentially have. However, if we change the direction of this for loop and start from the deepest parent nodes, we're going to have fewer recursions. As we go up in this tree, a lot of these nodes are going to be in the right position, so we're going to have fewer recursions. So to further optimize this algorithm, I'm going to set I to array.length divided by 2 minus 1. This expression returns the index of the last parent. So I would prefer to extract this and store it in a separate variable, last parent index. So we set I to the last parent index. As long as I is greater than or equal to 0, after each iteration, we're going to decrement I by 1. So this is how we optimize the heapify algorithm.